Beyond Cutting Edge with Bob Lazar. After Big Bang, Dark Matter, Dark Energy, and Universe Expansion debunking in my book Time Matters from 2021, I asked myself how hard could it be to validate Bob Lazar's story. So, I started with the Frozen Candle episode, because it was about time dilation, and I am very good at it. And besides, this episode, on the surface, contradicted with my own experience described in Chapter 12. But all new physics has checked out. The same result was with another episode, and another. Now I agree with Dr. Edgar Mitchell, Apollo 14 astronaut, who said about Bob Lazar. His basic story is true, that he was too exposed to what he thought were alien craft and attempts to engineer and back-engineer it. I think that his explanation of what's going on and his theory that he's utilizing is probably not on target. In plain English, Bob described real events, but he used wrong theory when trying to explain the observations. But now we have the right theory. This book starts with it, though you can skip it, except for Chapter 1, which is must-read, and it checks out with Bob Lazar's anecdotes. Reading this book does not require advanced knowledge of physics. A teenager with the help of a science teacher or with the help of the internet can understand it. Understanding reflection and refraction would be enough to start with. This book can be read two ways. Chapter by chapter, but that might be boring to you. Better try another way. Read Chapter 1 to get a grasp on time dilation, redshift, and refraction. Then jump to Chapter 13 and continue reading there, sometimes going back to earlier chapters when they are referenced. Read free Beyond Cutting Edge with Bob Lazar at .play.google.com or at amazon.com. Minnesota 1979 and Moscow 1980 cases are not UFO. In 1980, in a deserted suburb of Moscow where new Olympic Village was built, a few weeks before Olympics opening, so almost nobody was in the village yet, except for the Russian team and a few services, I and two other guys were at a bus stop. It was a brand new bus line, the only bus line on this road. Everybody boards when a bus arrives. I was the first who came to the bus stop, and I did not see the previous bus leaving. Then two more guys came, and we waited for a bus approximately 10 minutes. We saw nobody else around on our side of the road. Then we saw our bus approaching, dropping its speed, and it hit a woman that appeared from nowhere unexpectedly. She appeared with a foot still on the sidewalk curb, but her body was already over the crosswalk. Luckily the bus had slowed down by then, and the driver stopped it immediately, and did not run over the woman. We rushed to her, with the driver screaming, "Where did you come from?" She sat down and said, "I'll go home," but we laid her down comfortably and the driver called for an ambulance by the radio. His bus was new, but now it had a significant dent at the right front. There are many YouTube mockumentaries and animations on this subject. But I was at the accident, and I touched the bus and the woman. And the driver and two other guys stated the same. They did not see the woman until she was hit. And the woman was in shock from the hit, but not confused. That accident made me curious about space and time. I started looking for a clue that could solve this puzzle. Eventually, I learned that spatial explanations often lead to singularities. That's bad. Spatial explanation for this woman appearance would be teleportation, which does not survive my critique. But a solution based on time dilation seems plausible. The woman arrived with the previous bus. She approached the crosswalk. At this moment, around her, red circle area in the drawing, time dilation happened. A physicist would say a gravitational wave arrived, let's say with z equals 1000. We previously discussed that a big redshift z value causes strong refractions and makes the inside area stealth/invisible to an external observer. For 1 second of woman's time, 1001 seconds, 16.7 minutes, passes for an external observer, for me or any guy at the stop. When our bus approached, let's say 15 minutes after the previous bus left, for the woman less than 1 second passed. She hardly made her first step to the crosswalk, and for her, other people movements around the bus stop were too fast to notice. From her perspective, everything outside the red circle was moving 1,000 times faster, hard to notice and to understand in less than 1 second. The approaching bus knocked her out of the red circle into our time, so we saw her only then. Though this solution is incomplete, it is a good start. And it is based on time dilation, which has been successfully applied to solve various problems in this book. In this accident we had no material evidence for time dilation. But recently I came across a well-documented accident that happened in Minnesota in 1979, where sheriff's deputy's car clock and his wristwatch showed 14 minutes time dilation, meaning he was inside a time bubble. Details are at u2.b. Investigative documents are provided by the Marshall Company Historical Society. Society. Minnesota's case is an inside time bubble view, and my story is an outside time bubble view for the same type of events. Comparing these two cases, most likely sheriff's deputy's car hit something normal, like the bus hit the woman when she was inside a time bubble. And we discussed that time dilation area acts like lens, similar to magnifying glass. Dot and light coming from outside of slow time area is blue shifted inside the area, and visible or infrared light outside becomes UV light inside. That might explain sheriff's deputy burns on skin and eyes doctors found. Such injuries are common in arc welders exposed to UV radiation. Read more in Free Time Matters at play.google.com or at amazon.com.
That can actually alter the flow of time. I mean, that's the missing piece of pie.
Didn't they actually freeze a
candle?
A flame for
Yeah,
you?
now that's when it was connected to the gravity amplifiers.
Bob Lazar, frozen candle. Bob tells a story about how they lit a candle and when they pointed the reactor output on it, candle flame remained luminous and stopped moving. Bob described that the time slowed down at the area where they put the candle. The candle. The rate of slowing down, see chapter 1, is expressed in z plus 1, where z called redshift. Let's say it slowed down 101 times, could be any, should be measured at the site. So, if Bob stood right next to the candle, both for him and the candle, the time slowed down 101 times, so he would not notice anything weird about the candle flame, because time flow is the same for him and the candle. But when he stood outside, for 1 second passed inside the circle, 101 seconds greater than 1 minute passed for him. That is why candle flame does not flicker from his perspective. Watching the candle is like watching video at 100 times slower speed. But the most puzzling in this story, both for him and for myself, look at chapter 12 to see why, was that he could see the candle. Our expectation was, it should be screened from us, turned out it is not true, or to be exact, not always true. By now you should be familiar with Snell's refraction from page 6. Sin R equals 1 plus z, sin b. Let's notice that for a large number z, 100 for example, if angle b is not close to 0, for example b greater than 1 degree, b of 0 degrees minus 90 degrees range, 1 plus z, sin b will become greater than 1, and that cannot be, because on other side it is sin r. Only light that is almost perpendicular to the time zone's border can cross it. What happens to the light that reaches the border at the angle far from a perpendicular? It bounces back equals reflects. And reflection law states that light bounces back symmetrically under the same angle. Here is proof. For the light inside circle, only very close to to a radius that is always perpendicular to the circle, light can get out. And the light that is reflected back will continue reflecting again and again, because of the property of the circle, angle to the radius remains same. Same. Now, regarding visibility of the candle, we will have several cases. Visible. We can see the candle on the screen where it is marked in orange. In this position of the candle and the observer can candle flame is visible on the screen, and its image is a bit enlarged and a bit shifted. Mirrored. There are positions at which the candle is still visible, but its image is flipped and is seen far away from the actual position. Glowing screen. If the center of the screen is inside the candle flame, we won't see the candle, but we'll see a glowing sphere. Luminosity will be low compared to the candle luminosity, because light is dissipated over the screen. The orange arc is huge. Invisible. And there are two areas of invisibility in white. D. Mirrored. There are positions at which the candle is still visible, but its image is flipped and is seen far away from the actual position. Glowing screen. If the center of the screen is inside the candle flame, we won't see the candle, but we'll see a glowing sphere. Luminosity will be low compared to the candle luminosity, because light is dissipated over the screen. The orange arc is huge. Invisible. And there are two areas of invisibility in white. But in still can be seen at a different angle, from another position. Wavelength and visibility. Another aspect of visibility is wavelength. Our eye can see only a certain range of wavelengths, usually at wavelengths from 380 to 700 nanometers. Visible light, when redshifted or blueshifted, can become invisible. If 380 to 700 nanometers wavelength doubles, then 760 plus nm light is invisible to a naked eye, and if it is blueshifted to a half of wavelength 350 nm, then it is invisible too. And on the contrary, some light spectrum which was invisible can become visible after redshift or blueshift. In the story with the candle, we shall wonder why the candle light is still visible after strong redshift, caused by time dilation. Candle light is produced from chemical reaction between candle wax molecules and the oxygen, from electron interactions of C and H atoms of the wax and O atoms from the air. Atomic time is autonomous, independent from the time of the environment, space. So, change to the wavelength of the light emitted by the candle flame occurs twice, from point A to point B, and from point B to point C. From point A to point B wavelength increases, Z plus 1, times, and from point B to point C it decreases, Z plus 1, times. So, to the eye, point D, it arrives unchanged at a visible range for the eye, in a usual spectrum at which candles glow. I simplified the explanation, Actually, time in the candle A could be different from normal time at C, and normal time at C could be different from time in the ID, but point is, adding layer B between A and C does not change A to C wavelength ratio, because it is multiplied by Z plus 1 between A and B, and then it is divided by Z plus 1 between B and C. Intermediate redshifts cancel out. Wavelength B, wavelength A, wavelength C, wavelength B. Wavelength D, wavelength C, equals wavelength D, wavelength A. And wavelength 1/second, is in reverse proportion to time. Faster time corresponds to shorter second and longer wave. Wavelength D, wavelength A equals second A, second D. Thus, visibility depends on time speed at the beginning and at the end. For some other cases, when light is bounced/reflected, beginning is not at the reflection point, but before. Read more in free Beyond Cutting Edge with Bob Lazar at play.google.com or at amazon.com.